This conference will now be recorded.
So we had already covered uh, what is error and what is error analysis. So those things we have already covered. Today we'll be learning two things. Like one is, so this is our aim today. One is significant figure or significant digit, and the second thing is dimensions of physical quantities and dimensional analysis. We'll see these physical significant digits or significant figures. We'll learn first, and then we'll learn uh, the dimensions of physical quantities. Okay. So see, these are topics which are coming under units and measurement, that chapter itself. That is a actually long chapter. Anyway, we are almost done. At the most, we will take one more class on this, like dimension analysis. So see, this significant figure, you know, in the measurement, it is very important to know how you write a result. So what is important in experiment? How to write a result. How to write the experimental result, I should say. Experimental result. So that is very important. We had already learned somewhat that we have to write experimental result. Suppose L is equal to this is the final result. Suppose L prime. This is L plus or minus the absolute error, delta L. Okay, mean absolute error, right? So this is what we have already learned in the last class. Now, when I am writing this result, I'll be finally writing some numbers, right? I'll be writing some numbers. Suppose I write 1.62358. See, many numbers may come. Nowadays, we are using calculators. In the calculation, you'll see if you just divide 17 by 3, you will get many numbers. Suppose this will be somewhat this, and then you will get uh, again 6, maybe many more, right? So you'll get at least some 8 to 10 digit like this. Okay, but how many digits you should write? Actually, that depends on few factors, and that's why this significant digits or significant figures comes. Okay, so this is the context. Like when we write experimental result, how many digits we should write? Okay, how many digits are significant to write or reasonable to write? Obviously, that depends on, see, after decimal point, how many numbers you are writing. That depends on the precision of your experimental instruments. Okay, that depends on the precision. Okay, let us see as a definition what we can write about uh, this significant figures or significant digits. So as a definition, I'll just write it. Let me just clean this. Okay, yeah. So it is actually significant figures are normally those figures, those digits, those digits in a measurement measurement or yeah, or measure quantity, or measure quantity, those digits in a measure quantity, as I'll write measure quantity, those digits in a measure quantity which which are known which are known reliably. That means those will not be anyway reliably, those known reliably or certain. Okay, certain. And so normally those digits in a measured quantity which are known reliably or certain, plus the first digit digit of uncertain figure. Okay, uncertain or uh, not reliable digit. Okay, or first digit of uncertain, or first uncertain digit, I'll write first uncertain digit, first uncertain digit. Okay, first uncertain digit. I'll give you an example so that you will understand better. So what is the definition? Normally those digits in a measured quantity which are known reliably or uh, I'll write certainly, plus the first uncertain digit. I'll just give you an example. Suppose you are doing an experiment at the time period. Okay, time period of a simple pendulum, suppose. And look, this may be the time period you have measured in second. Like whatever uh, stopwatch or any watch you use, that can certainly measure or reliably measure these two quantities, these two digits, 1 and t. These are called actually sorry, certain or reliable digits. So 1 and 6, these are called reliable digits. Okay, reliable, because you can measure these two digits. Okay, but this is actually uncertain digit. Uncertain, why uncertain digit? It may be 2, it may be 3, it may be 4, or anything. So that's why it is called uncertain digit. So as a whole, this is a significant number, and it has three significant figures. How many? Three. Okay. So there are three significant digits. Three digits in 1.62. Okay. So you might be thinking, sir, can you give me one more example so that things will be clear to me? Yes, I'll give another example. Okay. So I had, see, I can measure length also. Suppose I'm just measuring length of any object. Okay, with my centimeter scale. Okay, and suppose you write the length of that as 273.6 centimeter. Okay, so how many digits are significant digits over here? How many are significant digits over here? Actually, these are certain numbers or reliable numbers. Reliable. Okay? Reliable. And this is uncertain. And this is the first digit of the uncertain number. So I can write, even I can write many more, 1, 2, 3, etc. Okay? But these are uncertain digits. So, but in the significant number or significant figure, I should keep only the first, see, the first uncertain digit. So the first uncertain digit I have to write. So 6, 6 is first uncertain digit. So the question will be, you will be given a number like this, and you will be asked to write how many significant figures are there in this number. Significant figures are there. Okay, this will be the question. So in this case, look, there are 3 reliable, 1 uncertain. So 3 plus 1, right? So how many you have? 4 significant digits. Significant digit. Okay. See, there are certain rules. We'll just go through those things, like how to find out. If I give you any number, whether you will be able to uh, find out how many numbers are significant and how many are not significant. Okay. So that will be the question in your exam. Let us see if I give you certain number. Okay, so you have to tell me what is the significant, like how many numbers are significant in that. Okay, you have to tell that answer. Okay, so suppose I give you a number 2 3 2 2.308. Okay, so how many significant digits are there? SD. So how many significant digits are there in this? Okay, suppose this is some length and this is meter. So what does these 3 points, actually 3 decimal points, what does this means? Actually, this means the precision of measurement or measuring instruments. Precision of measuring instruments. Okay, these 3 numbers are saying about or talking about the precision of the measuring instruments. Okay, so here you look, there are 4. 2, see, these are all actually so there are 4. 1 2 3 4. 4 significant digits are there. So how many are there? 4. Okay, now if I change the unit of that, suppose this is meter, if I write in uh, some other unit, whether it will change. Okay, whether it will change. Actually, with the choice of unit, number of numbers of significant digit SD does not change. Okay, so if it is, suppose it is in centimeter, then you convert it to meter. That means 0.02308. This is meter. If suppose this is centimeter, in centimeter this is the meter. After conversion of unit, So you have, see, two zeros extra, but those are actually not significant. These are not significant. Not significant. Okay? Significant. So there will be only four. This, this, and this. So as I said, choice of unit does not change the number of significant digits. Okay, so I'll just tell you. Um, Let me see how many are. Okay, so there are, we have, okay, Bala Murali and Deepa. So what I'll do now, I'll just write one rule for this significant digit, how to find out significant digits. Okay, there are certain rules. See, the rules are like this. First is, suppose all non-zero digits are significant. Okay, all non-zero digits are significant. This is one rule. You have to read in your textbook. It is nicely written. Are significant. Okay, significant. I'll just give you one example. What is that example? Let me tell you that this is some number 13.75. Okay, so see, there are no zero, so all non-zero numbers. So these are all actually significant. So you have how many significant digits? 4. Okay, 4 significant digits are there in that. Now you may think that, sir, in the experimental result we may be having zeros also. So whether zeros are not significant? Yes, there are certain rules. Some zeros will be significant, and some zeros will not be significant. We'll see that. So all zeros between two non-zero digits are significant. Look, all zeros between two non-zero, sorry, we can write two significant digit or two non-zero digits. Two non-zero, I'll write non-zero digit. So if there are zeros between non-zero digits, okay, they will be significant. Okay, they will be significant. They will be significant. I'll give one example to you. Suppose I write that I have a bike and I ride the bike to go some place, and see my uh, meter is showing that I have gone 100.05 kilometer. I have traveled 100.05 kilometer. So in this case, can you tell me how many digits are significant? Here, see, this is non-zero 1, this is 5. All zeros are between two non-zero digits. So all will be significant. All zeros in between two non-zero digits are significant. So you have as a whole 5 significant digits in this number. Okay? How many? 5 significant digits. Okay? All right. Now, another example I can give you, that all zeros of non-zero digits which are actually on the right hand side. Okay? Right hand side, or it is called trailing zeros. Okay? Trailing zeros. I'll clean this too. So third point is actually trailing zeros. Zeros in a number. Okay? Okay, Okay, trailing zeros in a number if they are if they are uh, right of some non-zero digits but left of an understood decimal points are significant. Okay, see all zeros on the right, if they are right to non-zero digits, actually they are, so then they are non-significant. Significant. I'll give you an example. So suppose I write 8 4 6 0 0 some number. Okay, 84600. So in this case, look, these are actually, see, these zeros are actually, there are no decimal points. Okay, in this case, you look, there are no decimal points. So the trailing zeros, okay, trailing spelling will be 1L. Trailing zeros in a number with decimal points will be significant, but in this case there is no decimal point. No decimal point. There is no decimal point. So these zeros are non-significant. Non-significant. Okay. Significant. Okay. So I'll give another example on this. See, if I write 15000, okay, then these zeros are non-significant. So it has only two significant digit SD. Okay, only two. In this case, three will be significant digit. Okay, but see, tell you one thing. If like all, see the trailing zeros which are uh, the trailing zeros in a number with decimal points. So trailing zeros in a number with decimal point are significant. Significant. Okay, right. So let me give you an example. Suppose I write a number 3.500, one number, or maybe I write 0.0900. See, in each of these, see, generally a number which is less than 1, this is less than 1, this number. In this case, generally when we write a decimal number, we put a 0 over here. This is actually always non-significant. Non-significant. Just before the decimal point. If it is a number which is smaller than 1, okay, or lower than 1. This is not non-significant always. Okay. So look the other numbers. So look this. How many you have significant digit? There are 4 digits. Okay, 4 digits are significant. And how many here? Actually, in this case also, you know, this case also, these are only significant digits. There are four. I'll tell you one special rule for that. Like, just a minute. See, if the number is less than zero, sorry, less than one, and zero is on the right hand side of the decimal point, but it is just left of a non-zero significant digit. So 6 is the non-zero significant digit just before the zero. That's why this zero is also non-significant. Okay. See what we have learned. These 2 points I'll just discuss once again. Trailing zeros. Don't get confused. Trailing zeros in a number without a decimal point. Okay, decimal point are non-significant. Okay, non-significant. Just try to understand this. I'll give example. See, I have a number, suppose 123 meter. Okay, I can write this. Uh, see, I can write this as 123 three zeros millimeter also. Okay, so in this case actually both are meaning the same thing, only thing is different units. So in the beginning itself I told that units, if you just convert, like change the units, does not change the number of significant digits. Okay, and see there is no decimal point also here. So what I said, trailing zeros or the terminal zeros without, like in a number without without decimal point are non-significant. So you have, these are actually non-significant. Okay, non-significant digit. So you have this. So this three will be is significant digit. Okay. Okay, the next point you learn once again. So if you have decimal point, okay, so what happens in that case? So it is saying that the trailing zeros in a number, suppose there is a number which is less than 1. Okay, suppose you have some number less than 1. Okay, as I can take this 0 0 2 3 0 8. This is a number. See, I have zeros like in the and I have decimal points here. Decimal points. See, after decimal point, I have two zeros. Then these numbers are there. So we have learned already, if there are two non-zero digits, and in between whatever digit is there, zero is there, that is actually significant. So this is significant digit. Okay, this zero is significant, and 2 3 8, these are also significant. Okay, this is significant digit. So what about these three zeros? So in decimal point, see, less than one number, the number which is less than 1, generally we put a 0 before the decimal point. So this is non-significant, always non-significant digit. Okay, this is non-significant digit. What about this two? It is said that if an in a number where there is a decimal point, if the zeros are just right side the decimal point, see, this is the decimal point and this is the right side of the decimal point, but those zeros are left of non-zero significant digit. So this is 2, which is non-zero significant digits. Since they are left, they are situating or they are sitting left of this uh, significant digit, non-zero significant digits. So these two are also non-significant. That's why when I wrote a number 0.00694 or 3 whatever, this number, how many significant digits you have? You have only these three, SD. Okay, I hope you understand this. Okay,
Yes, sir.
so is that okay for you? See, now I'll just give you one more decimal point and zero case. Okay, so suppose you have a number greater than 1. Okay, number greater than 1 without decimal point, and a number with a, okay, so those we have already discussed. So if you have a number in between two non-zero digits like this, so it will be your significant. Even if there is a point over here, this will be significant because it is in between significant digits. This will be significant. So total will be 3 significant digits. Okay. Okay, so these are few rules. uh yeah, so these were few rules in your book. It is written in a bullet points, like I'll just show you in your book. So this portion you have to read carefully and you have to learn it, because there will be some multiple choice type questions in this uh portion. In your board also, sometime questions will be asked from this portions. Okay, look, these portions you have to read carefully. Okay, now we'll learn one more thing here. When you have, see, such numbers, you have to do various arithmetic operations. Okay, arithmetic operations. So then what do you do? How to find out significant digits and how to write the final results? Let us discuss that also. Okay, oh, just a minute, I'll delete this. Okay, so suppose you have two numbers, they have their like significant digits, etc. you have. Okay, so what we are learning now is the arithmetic operations. Okay, so actually these are rules for determining significant digits in arithmetic operations. Okay, suppose I have to multiply two numbers. Okay, I have to multiply or divide two numbers. Then, so how do you write how many significant digits you should write in that? Suppose I am just giving one example from your book itself. So suppose I'm doing a division. Okay, this divided by, so this suppose density, density of some quantity. Okay, so this much gram, and then you have to write the volume. Volume is 5 to 7 this cc, centimeter cube. So then you'll get gram per cc, how much? 1.69 gram per cc. Okay, gram per centimeter cube, this will be result. See, but there are actually, see, this number has how many significant digits? 4. See, 1 2 3 4. This is 1, this is 2, 3, 4. 4 significant digits are there. How many significant digits are here? Only 3, right? Or after decimal point, how many digits are here? 3, here 2. So the rule is that if you take two numbers, suppose I write 2.5 and 0.005, 1 and multiply this. Okay, so this will be 225. So these are 1 2 3 and 4. So you have to write another two zeros over here. Okay, this is actually the result. But how many significant digits you should keep? So this is a different case. Okay, so I'll just not take this one. We'll discuss this later in the okay. So let us see with this itself. So when we just use a calculator, it will give many digits. Okay, many digits after decimal points. But how many decimal points you should take? Actually, the rule is saying that you should take, see, I'll tell you exactly how many digits you will get here. If you just do this operation with your calculator, you will get digits like 1.68804, etc. You will get. But how many digits you should take? We always get confused. Okay, how many digits you should take? It is said that among these two original numbers, so these are original numbers with which you are doing the arithmetic operations. After getting the value, you should take those many decimal points which is there in case of a number in less number. See, in less number. So suppose here significant digit is 3. Here significant digit is 4. So you have to write your result with the less significant number. Okay, with the less significant digit equal to less significant digits. So there are 3, there are 4. So I have to write the result such that my result has only 3 significant digits. That means you have two numbers with which you are doing the multiplication, addition, or whatever. In that case, after doing the operation, you have to keep those many decimal points to get the equal number of significant digits as your original number. Like in your original number, the less significant digit you have in that number. Okay, this number and this number, both are the numbers here, original numbers, but this number has less significant digits. Then I'll follow my result to write this only. Okay, I'll write two decimal points like 2.51. Here I'll write 1.69 instead of writing these many figures. Okay, I hope you have understood this. If you read again, you will understand. Or if you have any doubt, you can tell me now. Okay, so in addition subtraction also, suppose you have, so addition, in case of addition or subtraction, addition or subtraction. So what, uh, suppose I have two digits here. So 343.32 gram, 32 gram, and you have to add with that uh, 227.2 gram. So these two you have to add. So let us add this. So this will be 2 5, then 6 7. So this is 3. Okay, so this will be the number. Okay, if you do, okay, so yes, so this is actually your addition. After addition you get this number. Okay, but how many significant digits you should keep here? How many decimal point? You have to look the original numbers which has less number of significant digits. You have to follow that. So see, look, this one has less significant digits. 1 2 3 4, 1 2 3 4 5. So you have to write this result 663.5. Okay, so you have to write in this. Okay, this much gram. Okay, not 52 gram, because the rule is saying that saying that you have to write the result in terms of less. See in the see with the you have to write the number with significant digits having the same as the less significant original number. Okay, less significant digits, same number of digits in the original number, but which has less number of significant digits, that you have to follow. Okay, all right, so I'll not waste much time in this again. So this is all about this point. Okay, so what we'll do today, uh, so you just read this point, what is significant digits and significant figures, and what are the rules, how to find out significant figures if you are given a number, like how many numbers are significant, etc. So those you have to practice. uh, Let us start with our new thing today, that is dimension. Okay, dimension of physical quantity, dimensions of physical quantity. Okay, so if I say dimension, then you need to know what what does that mean first of all. Okay, so we have, in this physical world we have many physical quantities, right? Many physical quantities, and all the physical quantities, see, all physical quantities can be derived or expressed in terms of seven fundamental physical entities. Physical entities. Okay. What are those physical entities, like fundamental, seven fundamental entities? So actually these fundamental quantities are called seven dimensions of the world. These fundamental quantities, seven fundamental quantities are called uh, the fundamental quantities. So seven dimensions of the world. Seven. Okay, these seven fundamental quantities are known as the seven dimensions of the world. Okay, okay, let us see. And this, these dimensions are actually denoted or written inside this square brackets. Okay, this is called square bracket. Okay, and generally the dimension will be written in a by like by letter. Suppose if I say length, then I'll write the caps of that letter, capital letter. Okay, if I say mass, mass we denote by m, so we'll write m. This is the dimension. Okay, okay, so I'll just tell you what are seven fundamental uh, dimensions, or I'll write seven dimensions of the world. What are those? uh, First is dimension of length, dimension of length, and that is denoted by L. Then dimension of mass, denoted by M. dimension of time. So these are actually three fundamental things: mass, time, and length. Most of the entities can be expressed in this. Okay, these three. We'll see that. This has dimension t. Then you have dimension of electric current. Electric current. Electric current. This is actually ampere, so it is written as a like this. Then you have dimension of thermodynamic temperature. Thermodynamic temperature. Temperature. Okay. So that is denoted by K, capital K, Kelvin, because it is Kelvin. Then you have dimension of uh, luminous intensity, right? Luminous intensity. Intensity. I hope you have learned this in your previous classes, maybe somewhat. This is called candela, written as CD. Okay, with a within a square bracket. And then the last one is actually the dimension of any substance that is written as mole. Okay, like this. So these are seven fundamental uh, dimensions. In fact, any quantity, any physical entity in this world can be expressed combination of by various combinations of these uh, seven entities. Okay, seven quantities. So now, what do you mean by dimension of a physical entity? So what is dimension of any physical quantity? Physical quantity. So the answer is the dimension of a physical quantity or dimensions. Okay, the dimension of a physical quantity is the power. See, is the power to which the fundamental quantities mainly length, mass, and time. Okay, quantities must be to represent that quantity. Okay, to represent that quantity. I'll give you one example. Suppose I write uh, density of any substance. Okay, density, denoted by d. So this is actually mass by volume, right? Mass by volume. So the dimension of mass, we know, we can write capital M. And look, I have volume means three lengths are there, L cube. Then you have three length, breadth. Actually, you have length, breadth, and height. I'll just write in elaborate maybe. See, there will be length, then breadth, okay, and then maybe height. So these three things are actually nothing but length only, nothing but length only. So you get density, dimension of density as this m, and see length into length into length, because length, breadth and height all are having dimension of length only. That's why I have written that. So I can write, what I can write this as L cube I can write. So I can write this as m and L to the power minus 3. Like this I have to write. Okay? And you can even write like this also. M to the power minus 1, L to the power minus 3 all together. And t, we don't have any t. So if I write t to the power 0, nothing happens. Okay? So I can write this as the dimension of uh, density. Okay? So like that we can find out many such densities of various physical entities. So now I'll teach you what is called dimensional formula. Actually, dimensional formula is the expression which shows how and which of the fundamental quantities are required, and with the proper power to represent a certain quantity. So suppose density. So we need mass. Sorry, mass will be having plus power plus 1. Okay, and then you have length and time. If you write that is all right, then you have to write t is equal to 0, t to the power 0. So this expression is called actually dimensional formula. This is called dimensional formula. So this is see, it is actually a density, but we can write in this term also. In this way also we can write. So this is called dimensional formula for density. So if I want to write dimensional formula, so let us see dimensional formula for force. We know force means what? Force means we know mass into acceleration, right? M into A. So you have to find out dimensions of each of them. See, mass has dimension m. So what about acceleration? We know acceleration is v by t. Again, v means what? So distance traveled by time. Time. So you look, distance is L. This has dimension L. Okay, so you will get finally this is length L and this is t square. Okay. So what is the dimension of acceleration? L to the power 1, t to the power minus 2. Okay. What is the dimensional formula for the force? That is m. If you multiply both, like you just keep together. Okay. So m L to the power 1 and t to the power minus 2. This is called dimensional formula for force. Now if you write the force in the left hand side and write this, then this is called dimensional equation. Okay, this is called dimensional equation. Only this much. If you write m L t to the power minus 2, this is called dimensional formula for force. If you equate both of them, force in the left hand side, okay, and write the dimension of that in the right hand side. So this is called dimensional equation. Dimensional equation. Okay. So this is dimensional equation. So let us see. We will find out few more more dimensions. Like, see, if I write uh, what is the dimension of frequency? Frequency, you have read in your 10th standard what is frequency. Okay? Hertz. Hertz means what? 1 hertz means what? Or 10 hertz means what? A number per second. This is actually hertz, right? So it will be actually dimension of frequency will be t to the power minus 1. Okay? This is a dimensional equation for frequency. Okay? If I write for pressure, suppose I want to write pressure, dimension for pressure, dimensional equation for pressure. So pressure means what? I have force per unit area. Okay? So this is area. I'm writing, you can write this as area because A is ampere again, and this as force. Okay? This is force. Dimension of force by dimension of area. So force we have already learned. If you remember, m l t to the power minus 2. And area means what? Length square. Length square means L square. Right? So now you have to do some algebraic operations. So if L goes there, so it will be minus 2 over there, and minus 2 plus 1, so it will be minus 1 finally. L to the power minus 1. Look, I'm writing this. M L to the power minus 1 and t to the power minus 2. So this is the dimensional formula for pressure, and if you write here P or pressure, then it is called dimensional equation for pressure. Okay? So this is how you have to first learn various dimensions. You might be thinking, sir, what is the use of this? There are many use. We'll see. I will just define few more things over here. See, if a quantity is having no dimension, having no dimension, but its value varies, its value or magnitude varies. Okay, then this quantity will be called as dimensionless variable. Dimensionless variable. Okay, if it doesn't have dimension but does not vary, then it is called dimensionless constant. Okay, if something is not varying and also does not have dimension, so then it will be called as dimensionless constant. You will find many such quantities in physics, dimensionless constant. Okay, so those quantities are called dimensionless constant if the value is not varying and also does not have any dimension. So can you give one example of dimensionless quantity so far you have in your knowledge? See, dimensionless quantity is angle. We have already read. Angle means what? How do you define an angle? Suppose this is an arc of a uh, circular path. This is radius of that, and this is angle theta. This is how we define planar angle. Theta is, this is arc length divided by radius. See, the arc length, it is also length, and the radius, this is also length. So length, dimension of length both in numerator and denominator. So which will cancel. So this is why this is actually called radian or rad in small, but it is a dimensionless quantity. Similarly, three-dimensional angle, which is called solid angle, that is called stray radian, but that is also dimensionless quantity. Like specific gravity, you might have already learned. Specific gravity. Sorry, gravity. What is that? It is the ratio. It is the ratio of density of any substance to the ratio of density of any substance to the density of water. See, both are density in the numerator and denominator. That's why this is dimensionless. Okay, these are dimensionless quantities. So both are density. So if you divide, so density, the gets cancelled. Okay, so that's why these are called dimensionless quantities. See, dimensionless constant like see E, then pi means 220 by 7. It doesn't have any unit, no dimension. So if any quantity does not have any unit, that is dimensionless quantity. If any quantity does not have any unit called dimensionless constant. Okay? So I hope you are understanding and you should remember these things. Okay? And see, any physical entity like pressure, volume, sorry, pressure P, then maybe kinetic energy. So these are all variables, but having dimension. That's why these are called dimensional variable. These are called dimensional variable. So see, what we have to do is actually the main important point over here is the dimension analysis. Dimension analysis. Okay, I'll take another 2-3 minutes to conclude the class. Okay, dimension analysis. So here we'll be doing dimension analysis next class. Dimension analysis. So what do you mean by dimension analysis, and what is the application and its application? This will be learning in the next class, but I'll just give you brief introduction to this. So the method of studying a physical phenomenon on the basis of dimension is called the dimension analysis. That means, see, any physical entity we can analyze by their dimension. Okay, we can analyze that. How things will vary, like force. I write M L to the power minus 2. So I can see this and I can understand like how things will vary. Okay, all right. So the method of studying a physical phenomenon on the basis of dimension is called dimensional analysis. So what are the applications of this dimensional analysis? The most important is that any equation, if you are given any equation, any equation or any expression, you can easily find out whether the expression or equation is written wrong or right, true or false. Okay, then second one is you can convert. So first one is actually I'll write first one is actually you can convert physical quantities from one unit system to other unit system. Okay, like CCS to SI. Okay, I'll give one example. Yesterday, tomorrow, or like I think again we have Tuesday. So suppose 1 Newton means 10 to the power 5 dyne. Okay, 5 dyne, 5 dyne. So uh, this is actually can be done by this dimension analysis. Second thing is to check any equation or expression. This also we'll see. Okay, expression. And third is derive relationship between different physical entity. To derive relationship between various physical entities. Or I'll write between different physical entities. So when I say entity and quantity, actually both are the same. Okay, different physical. So these are three applications. So one is actually you can convert one quantity from one unit to another by the use of dimensional analysis. Second thing, you can check whether an equation or expression is correct or wrong. So that you can do by dimensional analysis. And third is you can derive a relationship between different quantities, physical quantities. Okay. So with this, I'll stop today's class, and next day we'll do thoroughly these three things: how to convert a physical quantity from one unit to another by dimensional analysis, what is the method, and some example. Then how to check whether the expression is correct or wrong, that also will do. And then third will do how to derive relationship between different quantities. So these three things we'll do in the next class on Tuesday. So for today, that's all. So thank you for your patience. Okay, so I'll stop it here.